Okay, this is day 3 of blind solving the daily Leetcode question. Okay, today is an easy 3, 3, or 4. Find the kth character in string game 1. Alice and Bob are playing it. Alice has a string word that equals A. We're given positive integer k. Now Bob will ask Alice to perform the following operation forever. Generate a new string by changing each character in word to its next character in English alphabet and append it to the original word. For example, if we perform this on C, it generates CD, and then ZB generates ZBAC. Okay, because Z loops to A and B loops to C. Okay, return the kth character in word after enough operations have been done in word to have at least k characters. Weird problem statement, but this doesn't seem that bad. I think this is going to come down to modding. But yeah, yeah, okay. Are we given the first character? Do we always start with A then? Yes, okay. We start with A. That's a massive help to us. I guess I should time this. I'll add a minute or so on. Okay, yeah. So if we're given A as the first character, then we know the length is going to double every single time we play this game. So we need to find, if we imagine, I'll open up Paint, makes it easier to visualize. We know that K is going to appear somewhere like here. For something that is a power of exactly 2n. So if we half this into its constituent pieces that were in the previous operation, so I don't know, like let's say k is something like, I'm just trying to choose a nice number, 25, then this would be character 0. This would be character 16 that lies into the right of this, and to the left would be character 31, to the right would be character 32. Imagine the characters like this. Okay. So this character that lies at position 25, all we have to do is consider 25 minus 16, which gives us 9. And this is going to equal to the same problem, but the 9th character plus 1, right? So whatever the 9th character is, if it's the letter J, it's going to be the letter J plus 1, which is K. Bad example, but if it's the letter G, then it's going to be the letter G plus 1, which is H, right? So if this is G, then this letter would correspond to H. And we repeat this kind of reduction of the problem. There's probably a nice way of doing this by converting 25 into binary. Is this worth the effort? Maybe. Let's see if it seems easy or hard. Yeah. So I mean something like 25 in binary. Well, we'd have a 16 here, and we'd have whatever the like if this relates to the 2 to the 4 place in binary, then whatever this sums up to would relate to the 9 in binary. So, we'd have 1, 0, 0, 1. Yeah, perhaps binary is a good way of doing this. To get the binary of 25, we repeatedly take 25 mod 2, which is 1, and we keep the 25 divided by 2. So this would give us something like 12. Then we do 12 mod 2, which is 0, divided by 2, 6, and we round down. Again, mod 2 divided by 2, 3, mod 2 divided by 2, mod 2 divided by 2, get nothing. And notice that this is the binary representation of 25. And the interesting thing that we can do is we can use this, I guess, to represent the problem as well. I mean, I don't know if there's any actual benefit of doing this, so maybe we won't do it. Anyway, this is, yeah, so this is, as we said, we just get a character and we can reduce it to the previous problem statement. We have the base case of if k is equal to 1, I assume we'll never get k equals 0. Yeah, if k is equal to 1, we just return character A. Otherwise, what we're going to do is we're going to take this intermediate answer. So like the sub answer is going to be the kth character of whatever k uh whatever the largest power that goes into k that's the power of 2 minus from k is, which is where the binary representation comes in, I guess. Um, yeah. Yeah, maybe there's a nice way of doing this. Mm, we know that for something like 1, the answer here is A. When we double it, the answer becomes B. Do I understand the question correctly? We know that this one relates to, so, A becomes AB, which becomes AB, B, C, A, B, B, C, B, C, C, D. Oh, yeah, it is pretty simple. It's literally just powers of 2. Wow. Wild. So it seems that we only need so like this is 0, this is 1 0, this is 1 1. You think this is, yeah. What? Um like 1 1 0 1 1 comes to 1 0 0 0 1 1 1 0 1 1. I mean, perhaps there's a more optimized way of doing this, but it does not seem bad. Yeah. So it boils down to, like, again, just to explain it, if we happen to have character 7 that we were interested in, well, we just look at whatever this kind of excluding the most significant character looks like, and then progress back to here, right? So we just want a quick way of excluding the most significant bit. I mean, yeah, this is the base case of 1. This is the case of 1 0. Sorry, yeah, 1 0 1 1. This is the case of 1 0 0 1 0 1. Oh, okay, I guess it is 0 1 here, right? Plus 1. So yeah, I wonder if we can build this up. Hmm, might be possible to build it up every time we get a 0 here. Cases should be 1 1 0 1 1 1, and again, this is 0 1 case. Oh, sorry, 1 0 case. Is this B plus 1? This 1 1 case. Is this B plus 1? Likewise, if we look at something like this, it's going to be this case plus 1. When we look at this, it's going to be this case plus 1. So does it come down to something else about the string? I'm wondering if there's a smarter way of doing this. Um, I mean, by this theory, if we have 1 0 0 1, that should reduce to B, right? C. Oh, sorry. Um, we have, yeah, would actually, wouldn't it? Yeah, no, this does seem to work. Because here, 1, 0, 0, 1, we can simply ignore the zeros and recurse all the way back to 1. So it's a matter of, hmm, it's not just about counting ones, but it kind of is. I guess, hmm, there's a question when we get the 0, 0 case. And 0, okay, so it seems that 1, 0, 0, blah, blah, blah cases are the base cases of this, and anything else recurses down simply. So yeah, we are simply counting these cases. Yeah. So what we can do is we can count the number of zeros until our first one, and that will give us the shift of the first character. And then we can ignore the zeros for the following characters and simply, I guess, yeah, we can just add the number of ones that come afterwards. I feel like that's a way of doing it. Of course, you can recurse and figure it out the other way, but this seems kind of nice. So, yeah, starting, I'll keep numbers for this. I'll say while a or 2 equals 0. I'll increment the starting number and shift k to the right. Then, I mean, I doubt I'll need to really mod because of overflow. And we'll say while k does not equal 0. If this happens, increment, I will continually shift to the right by 1. And then we'll return starting mod 26 plus a and make sure that this is character. And we'll see how good or bad that is. Might need a -1. 2 or something. I guess our starting number is 0 technically. Cool. Nice. Yeah. And I guess this is, I guess in a way, it's a logarithmic solution to the problem where all we care about are the number of bits that represent the problem statement, which is, I guess, better than any recursive solution that we were considering naively. But yeah, that's the daily code. Hopefully that helps.